We just finished all of our language mechanics and core language semantics. We're now going to be moving into design. And there's lots of interesting conversations we can have around design and interface and composition design. Again, we're still talking about decoupling. And there are going to be some quotes here that I want to just share that are going to come up throughout the remaining sections here as we continue to talk about design. This first one from JBD, who's Yana. She works over at Google. A good API is not just easy to use, but it's also hard to misuse. We're going to be talking about that design philosophy quite a bit as we continue to move forward. You can always embed, but you cannot decompose big interfaces once they're out there. Keep them small. Another really great guideline that we're going to be trying to follow. Rob Pike has a beautiful one here. Don't design with interfaces, discover them. That's going to be huge. And finally, Sandy Metz, duplication is far cheaper than the wrong abstraction. Yeah, so all of these ideas, including the idea that we want to make things easy to understand, not easy to do, all of these things are going to now come into play as we start to talk about design and design philosophy, leveraging the language mechanics and semantics that we've learned up to date. So let's get into some code again, and we're going to focus on the idea of grouping. Grouping is one of those things that can become a stumbling block for a lot of people who come into Go for the first time, especially if they're coming from an object-oriented programming language. We've talked about a little bit, but let's formalize this grouping discussion. I'm going to start with a little code, and this is code that tends to come up when somebody's having a problem with grouping. Especially, again, like I said, if they're coming from an object-oriented programming language. And normally, if I'm asked to help in this type of scenario, the storyline that the developer is coming to me with usually comes like this. They're usually saying, hey, Bill, I'm coming from an object-oriented programming background, and I've been learning Go, and I've been trying to apply some of those object-oriented techniques. And Bill, let me show you something, because I ran into a little problem, but let me show you where we're at. And so we start off there on line 14, and line 14 says, okay, Bill, I'm going to have an animal type. It's going to be like my base type for this program I'm writing. It's got a name. It can determine whether that animal is a mammal or not. We've got these common fields that all animals would be about. And then, Bill, I'm going to add some behavior to my animal. In this case, it's going to be speak behavior. Now, obviously, an animal in a generic form can't speak. We need to know what a specific animal is. But, we add the speak behavior anyway, just to have a complete piece of code. So there it is. There's my speak, even though the implementation is useless. And, Bill, if you're going to have an animal, then we're going to have a dog. So, Bill, I'm going to go ahead. I'm going to define a dog, and I'm going to embed that animal inside the dog. And, Bill, as you know, embedding means that now this dog has everything an animal is, plus anything that we extend. So that's on line 33 on the extension. Bill, just like in my object-oriented languages with inheritance, I'm getting that same feature functionality. I'm feeling really good about this. I now have a dog. And Bill, on line 37, now we have an actual implementation of speak. There it is. My dog knows how to say woof, and it's all working perfectly. And just to continue to add this idea that we can have different types of animals, Bill, I add another type called cat. If you're going to have a dog, well, you got to have a cat. And now we have that cat, and that cat also embeds animal. So now a cat is everything an animal is. Plus, Bill, we've extended that cat to now have a climb factor. And cats know how to speak, and then they have a different way of speaking than dogs. This one is going to say meow, and it's a good implementation. And Bill, now have two concrete implementations here, leveraging that concrete animal type to kind of reuse state and behavior, like everything I've learned how to do in object-oriented programming. But Bill, I've kind of come into a problem after this, because what I wanted to do was group dogs and cats together by the fact that they're animals, just like I can do in my object-oriented programming languages. And so, Bill, I went ahead and I created a collection, a slice of animal values. But the compiler is telling me that I can't add dogs and cats to this collection. And I'm stuck. So can you tell me what I'm doing wrong? At this point, what's happening is that this developer is used to the idea of subtyping, the idea that because a dog and a cat has this animal embedded inside of it, it makes them an animal, and therefore we can group them by the fact that they're an animal. We can create a collection of these things. We can move them around our program. And remember what we talked about during the embedding section, that embedding does not create a subtyping relationship. In other words, in this case, dogs are still dogs and cats are still just cats, and animals are not dogs and cats at all. And this becomes fairly confusing for developers coming in. So there's a few things here that we really have to kind of think about. And it goes back to the idea that when we're working in the concrete, we do care about what things are. But when we're dealing about decoupling, right, working with multiple types of data, decoupling, we have to move from what is down back to what does. What does a cat and dog do? That's how we really want to group things together. We really want to stop focusing here on what things are, including as we're doing these code designs. So if I see a design of code like this in Go, immediately it's raising flags because that developer's focusing on what is instead of what does. And there's lots of other smells in here that I want to kind of just start picking out. I want to start picking out in this code. A big smell that I see pretty quickly as well is that this type animal, it's really being defined as reusable state. Most of the time, that's a big smell. But the other big smell here is that we have an implementation of speak that is completely useless. We really have almost like an abstract type here that we're defining. These are smells in code that now we've got code we don't need, code we're not going to run, code we have to write tests for that are fairly useless. The also idea is that we want to define types that truly represent something new and unique. And I'm not sure here that animal truly represents something new and unique because there is no part of this code that's ever going to need an animal value. And it's a pretty good indication as well that this is a type that's kind of polluting our type system. So when I'm looking at all of this code, not only are the patterns around this code really not what we want to be doing in Go, but it's also lending itself to other bad smells. Again, that animal type providing an abstraction layer of reusable state. When we embed, we don't want to embed for state, we want to embed for behavior because that's where the decoupling comes from, the behavior, right? We notice the program never needs an animal value at all in order to function. Again, that also makes that animal type a bad smell. The implementation of speak, it's generalized and not going to be used, and now we've got to write test coverage for it, which is a total waste, and it's never going to be called. So what do we tell this developer at this point? How do they fix this code? What's the mind, change that we have to make here, right? How do we shift that mindset into what's a better way to do this in Go? And it's always going to be focusing on behavior. So what I'm going to tell these developers, stop thinking about what animals are, right? Dogs and cats are, and start thinking about what dogs and cats do. And once we identify what a dog and cat does, then we can go in and define those interfaces. One of the things that I'm going to be looking for in a code review is that interfaces always describe the behavior of things, not what things are. Our concrete types should define those nouns, those persons, places, and things, and interfaces should describe the behavior that those nouns, those persons, places, and things can do. And if I see interfaces that are describing things, that's also going to be a bad smell. And this goes back to Rob Pike's quote about discovering those interfaces, not designing with them. Because if you're designing around that behavior and you don't have a good concrete implementation of something, you're guessing. You're guessing. So we already have a concrete implementation of a dog and cat, and we don't have to guess about the behavior. It's there. It's called speak. So what we're going to do is add the speaker interface with that one active behavior, speak. We now have that behavior well defined. And now through the interface, that valueless type, we can start doing some decoupling. And I'm going to get rid of the animal type altogether. Remember what Sandi Metz said. She said, duplication is far cheaper than the wrong abstraction. And for me, that animal type is the wrong abstraction. It's adding no value other than pollution for all the reasons that we talked about. So I'm going to get rid of that animal type, and I'm going to use Sandi Metz's design philosophy on that duplication, and I'm going to copy that name and is mammal fields inside my dog. I'm just going to have that dog type. And because of the speaker behavior that's already there, a dog already implements the speaker interface. And I'm going to do the same thing with cat. Cat now gets its own name in isMammal. It's 2 fields, it's not a problem. You might say, well, Bill, what if we have to add another field? Then we add another field, it doesn't take that long. Well, Bill, what if I forget to add that field to that cat? Well, then obviously it wasn't important to be there, and now your types are much more precise around what they need to be at. So again, it's all going to work out at the end. And now a cat also implements the speaker interface on line 48. And now here's the beautiful part. If we want to create a collection of dogs and cats, we don't do it based on what we think they are, like animals. We do it based on the fact that they can speak. This really lends itself to a lot of flexibility in the code. The developers who are defining these concrete types don't have to think about the future use. They just define the behaviors that they need. And we can always start looking at that common behavior and group things together. And so now we can group dogs and cats together, not by what they are, but by what they do. And it's going to be a beautiful way of starting to think about decoupling all the time. Remember, the problem itself is solved in the concrete, but the decoupling, when that data is going to change, is solved in the behavior. So let's kind of summarize a few things here before we end here. And one of them is, again, I want you to always be declaring types that represent something new or unique, all right? And that animal type really wasn't describing anything new or unique. It wasn't something that we needed. We were trying to do some reusable state. And there's some other ideas around this idea of representing something new or unique. I see a lot of developers do things like this in Go. They're like, well, we're going to have this concept of a handle. So what I'm going to do is define a new name type called handle, and it's going to be based on an int. And Bill, I want to do that because I want to define a function, maybe foo, that takes a handle, and I want to be able to get the compiler protection. And look, Bill, look how readable that is. And I'm going to say we're doing something very, very fundamentally wrong here, at least in Go. Because if I ask you what a handle is, you're going to say, well, Bill, a handle represents this integer value that comes out of the operating system. I'm going to say, stop. I go, what did you say a handle was? And you're going to say, Bill, it's this integer value. I'm going to say, well, it's an integer then. So what are we doing here? There's no aliasing in Go. So why are we doing that? No, Bill, it's a handle. I want the compiler protections that I'm getting on line 86. I'm going to say, first of all, it's really not a handle. That doesn't represent anything new. It's an integer. And second, you're not going to get the compiler protection because I can always write code like this on line 87 where I can pass the integer 10 of kind int, right? The value 10 of kind int through. And because that's a constant of kind int and is compatible with handle, the compiler will do the implicit conversion. So you're not even getting the compiler protections you want. This is really bad. If I saw this in a code review, what I'd be telling you is get rid of that type and define that the parameter is name handle based on an int. This is more readable. We're not hiding anything. Anytime I ask you what that type is and you're giving me back as part of the answer the name of the base type, we really don't have a type that's new or unique. And again, you're not going to get those compiler protections because we can implicitly convert those built-in types when they're based on a kind. But here's a great type that does represent something new or unique. We would find it in the time package, and it's duration. And that's how it's defined in the time package. It's based on an int64. But if you asked me, Bill, what is a duration, I would say that represents a nanosecond of time. Notice I'm not using the base type to tell you what it represents. That truly does represent something new or unique. Much better than handle, right? Duration. Another way we can also validate whether or not this is a good type, new and unique, is if it has a method set. Most of the time when I see types declared like this, based on, off of a base, I want to see a method set of behavior that's reasonable and practical. So animal really wasn't fitting in any of that. That's why we got rid of it. We want to validate that if we do define a type, we need values of that type throughout the scope of the program somewhere, okay, somewhere. And if we don't see that, that's going to be another smell that type is pollution. We always want to focus on embedding types for behavior, not for reusable state. Remember, there's exceptions to every rule, but those other design patterns are really not what we're going after in Go. So if we're going to embed, let's really focus on the idea that we're doing it to share that behavior. And I want you to always question any type that exists that is there for an alias or an abstraction and whose sole purpose is to share common state. So this is the beginning of our understanding around composition, because composition is about, right, bringing different types of data together in collections and in groups. And these are our first lessons that are going to take us into our next exercise, which is a composition example.